This video is an introduction into some of the more prominent technical patterns that we find in domain-driven design. The concepts I will be covering will be entities, value objects, aggregates, repositories, domain services, and domain events, as well as a couple of other topics that may be of interest. An entity is a domain object that has a unique identity and lifecycle. If we take something like a customer, for instance, we might have more than one customer with the same name, such as John Doe, so that is not unique enough. However, we could use some other properties such as address to look up the customer, but we want to assign a unique business identifier such as a customer number to that specific customer so that we can interact with the customer using that customer number. Behind the scenes, we want to assign a surrogate or synthetic key such as a GUID, which we can use to create relationships with other objects within our domain. A value object, on the other hand, has no identity and only represents state. If we take something like a money object, for instance, if we have $10, we do not care if we have two instances of $10. They're both, for all intents and purposes, identical since they are representing a specific value. Email addresses, if we have two email addresses that are exactly the same and we have two instances of an email object, we don't care. They are both the same. We do not care about a specific instance. Paint, red is red. We don't care if it's red 1 or red 2. These things are going to be exactly the same. They do not have an identity. An aggregate is where things start to get a bit more interesting. It has an entity as a root and usually some other value objects, and all the objects that are part of the aggregate share a life cycle. So should the root entity be deleted, all related objects will also be deleted. Now, deleting is something that we shouldn't really be doing in our business system in any event, but that is the concept behind it. The aggregate as a whole is either in existence or doesn't exist at all. Identifying aggregates may be rather tricky, but this is where we need to talk to our domain experts, look at the ubiquitous language, identify those parts of the system that have a common life cycle and that belong together. If we look at something like grapes, we might have something like a stem, which has a collection of berries. A berry has a weight. The stem might have a weight. So in order to get the total weight for the stem and the berries, we might have a method on the stem that says get total weight. And that might seem slightly odd if we can change the design ever so slightly and say, okay, well, we'll have something called a bunch. That is our aggregate root. And that contains a collection of berries and it contains a stem. So this is where we need to understand the domain a bit better and where we need to talk to our domain experts to see what is a more appropriate design for a situation like this. Since this is just hypothetical, there is no right or wrong answer. A domain event represents a state change in your domain. A customer might phone in and say, listen, I've got a new address, and you might want to invoke the move method on the relevant customer instance. And as a return object from that method, you might receive a customer moved event that can be, using some notification pattern, be passed on to other bounded contexts where they can respond to that event and do something in their respective bounded contexts. This also works well with event sourcing, where these events are then stored in an event store and can be later played back into your aggregate root to rehydrate your aggregate root. But I'll be dealing with event sourcing in a later video, so keep an eye out for that. A repository is used to retrieve aggregates. In the original domain-driven design book by Eric Evans, there is a diagram that actually shows that entities can also be accessed with repositories. So that just basically means that that entity has no related objects, which means that it is not an aggregate. But you can think in terms of aggregates all the time and say, okay, well, repositories only return aggregates. If that aggregate happens to be a single entity that's encapsulated under the concept of an aggregate, then that's also fine. A repository typically acts on a single aggregate root. An aggregate root is considered by many domain-driven design practitioners as also being the transaction boundary. So only a single aggregate should be operated on within one transaction. Now, although this is an ideal to strive for, if we need to bend those rules a little bit, it's not going to be the end of the world. A domain service represents interactions that don't fit on a domain object. You typically run into these when you either need more information in order to complete an operation, or you need to act on more than one aggregate root within the same operation. This is one of those scenarios where we might need to bend the rules with regard to transaction boundaries around an aggregate root. There are typically two styles that you may follow when defining domain services. You might want to go for a more coarse-grained service that has more than one method on it, or you might want to define each operation as its own service using the command pattern. Application services contain no business logic and simply coordinate interaction with domain services and repositories. They essentially encapsulate the sequence of domain operations that you may want to reuse. Infrastructure services are not domain related but are still required in order to complete certain processes. Something like sending an email or perhaps a text message would require an infrastructure service in order to perform that operation for you. Something else that's not domain related but also quite important in your system is the ability to perform queries. You should not be performing queries against your repository since that works with aggregate routes, and aggregate routes typically are not going to be suited for querying. If you look at something like an order and its order items, when you reconstitute an order in this case, it's going to bring in all those order items, which is something that you don't want if you just want a list of orders. However, this is where something like lazy loading comes in, which is rather quite evil. So you start defining fetching strategies and the like, and that is adding a complexity to your system that you do not really require. A much cleaner approach is to be able to specify a query where you can only go and fetch the orders that you require for your query, display them on the screen and be done with it. So a very thin query layer is something that's going to be rather useful. Such a query layer can be as simple as complex as you like. You typically want to return the most primitive form of data that you can get away with. So if you want to return a count, you might want to only send back an integer, whereas when returning more data, you might want to return a data row. You may even consider returning a read model, which is a data transfer object that represents a more complex data structure. And finally, I'd like to touch on anemic domain models. These models typically only represent the structure in your design, with absolutely no behavior. You'll also find that you can navigate from one object to the next without any boundaries defined anywhere. We run into these types of structures quite often when dealing with object relational mappers. Since there is such a strong focus on data, there is no benefit in using these as a domain model. I think I'll leave it there for this video. Thanks for watching.